In April 2019, NASA announced plans to put astronauts back on the Moon by 2024 and build a permanent lunar base by 2028 under its Artemis program. According to IEEE Spectrum, NASA currently has the most detailed plans, but other countries are on a similar track. Russia said it would land cosmonauts on the Moon in 2031 and begin constructing a lunar base in 2034. The China National Space Administration is planning to build an inhabited research station on the Moon's south pole in the next 10 years. Even the European Space Agency is developing a concept for an international settlement called Moon Village that's meant to support various activities on the lunar surface. IEEE Spectrum reports that getting to the Moon involves super heavy lift rockets. For its 2024 lunar mission, NASA is relying on the Space Launch System, or SLS. China is looking to upgrade its Long March 5 rocket to a Long March 9, while Russia plans to use the Yenisei rocket but has only just finalized its design. Private companies like SpaceX and Blue Origin are also developing their own heavy-lift launch vehicles, the Falcon Heavy and New Glenn, respectively. Both use reusable stages, making them more economical than the SLS, which is not only over budget, but also 3 years behind schedule. As far as landing on the Moon, NASA is going with commercial lunar cargo landers from companies on its Commercial Lunar Payload Services program. In May, it awarded contracts to 3 companies, Astrobotic, Intuitive Machines, and Orbit Beyond, to carry payload and instruments to the Moon's surface. NASA's lunar plans also rely heavily on a space station called the Lunar Orbital Platform Gateway, which will allow a near rectilinear halo orbit around the Moon. Gateway is slated for completion in the mid-2020s. According to Space.com, NASA's 2019 fiscal budget request calls for a 2022 launch of the Power and Propulsion Module. 2 additional launches by 2025 will add habitation, logistics, and airlock functions. Gateway will serve as a staging post where astronauts can dock and leave their spacecraft, then travel to the lunar surface in a lander. It will also provide them shelter, a place to stock up on fuel and supplies and relay communications, and a base to dispatch crew and robots to the Moon. Once humans actually get to the Moon, the next step is building a permanent settlement, starting with habitats that are able to withstand extreme temperatures, radiation, and abrasive moon dust. IEEE Spectrum reports that some engineers and architects are using the same abrasive dust known as regolith or lunar soil to 3D print habitats. Walls can either be 3D printed all in one piece at the location where they'll stand, or as smaller materials like bricks that can lock together when stacked. Another approach called sintering, using solar power or microwave beams to heat regolith to near melting point until it fuses. There's also the possibility of inflatable modules that can expand to greater capacity. To support life on the Moon, habitats could use an open-loop system like the Apollo missions, where oxygen, food, and water are provided and waste disposed of on-site. A more likely system, though, would be the one employed by the ISS, which uses physico-chemical processes to recycle water and air on the space station. But for a habitat to be sustainable, it will need to tap into local resources. Water doesn't exist on the lunar surface, but is likely available as ice that can be extracted from the Moon's dark craters. One way to do this is by using a rover-mounted drill. Another concept called thermal mining redirects sunlight into a crater with heliostats, where it turns water into the regolith to vapor. The vapor collects in a tent and then condenses into pure water ice inside refrigerated cold traps. This can then be used to sustain settlers or broken into hydrogen and oxygen to create rocket fuel. With no GPS on the Moon, robotic rovers will also need to navigate the lunar surface and produce detailed 3D maps of the terrain. Many more scientists are working on lunar projects, developing tech to allow high-bandwidth communications between Earth and the Moon, for example, or setting up a radio observatory on the far side of the Moon.